Hello students, let us continue the session on revision in the chapter area related to circles. In the previous session we had completed exercise 11.1. Let's begin with 11.2. Question here is the area of the circle inscribed in a square of side a centimeter pi a square centimeter square? Give reasons for your answer. For making it easy, I have brought in a figure. Here the circle is inscribed in a square and the side of the square is a centimeter and the radius of the circle I have taken as r. Here, upon observing, you'll come to know that radius is half the side, so it's a by 2, and the area of circle is given by pi r square. So it is pi times, instead of r a by 2 whole square, we'll be getting pi times a square upon 4 centimeter square. And this particular thing is not equal to pi a square. So the given statement is false. Second question. Will it be true to say that the perimeter of a square circumscribing a circle of radius a centimeter is 8a centimeter? Give reason for your answer. Again, I have taken a figure. In this figure, the side of the square is 2a, hence the radius is a centimeter. Since the question is related to the perimeter of square, let me find out the perimeter of the square. Perimeter of square is given by 4 times the side. Since I have named it as ABCD, I'll take 4 times AB. So it is 4 times 2A, which is 8A centimeter. So the given statement is a true statement. Question 3. In the figure 11.3, a square is inscribed in a circle of diameter d and another square is circumscribed. Circle is the area of the outer square 4 times the area of inner square. For better understanding, I'll label the figure and I'll consider the diagonal of the square, which is the diameter d. Let the side of the smaller circle, which is smaller square, is a units and the bigger square is b units. Here, diagonal of square E of GH is the diameter d. From the Pythagoras theorem, we have the square on hypotenuse equal to sum of the squares on other two sides. So it is a square plus a square. Hence we will be getting a square as d square upon 2. If you observe it properly, a square is nothing but the area of smaller square, that is d square by 2. Now observe carefully the outer sides square has got side b units. This side is nothing but the diameter of the circle. So area of square ABCD is B square, which is same as D square. Let me write this D square as 2 by 2 times D square, which is 2 times of D square by 2, which is 2 times of area of small square. So it will not be 4 times, instead it will be 2 times. So the given statement is a false statement. Question 4. Is it true to say that area of segment of a circle is less than the area of its corresponding sector? So let me take the figure representing the segment and the sector. Here, area of the major segment, if I consider ACB, area of major segment ACB is greater than its corresponding sector OACB, isn't it? OACB, if I consider this, the segment's area will be adding triangle to the sector, therefore it is greater. At the same time, we have area of minor segment, I'll be naming this as ACB. The minor segment is smaller than its corresponding minor sector OACB. Hence, the given statement is a false statement. Area of segment will not be less than its corresponding sector. It depends on a larger segment or a minor segment. Question 5. Is it true that the distance traveled by a circular wheel of diameter d centimeter in one revolution is 2 pi d centimeter y? Here, the distance traveled by wheel in a revolution will be same as the circumference. It is the circumference of wheel. Here the circumference of the wheel is 2 pi r, which is 2 times r times pi, which is pi times d. Therefore, the given statement is false. They have given in the statement that it's 2 pi d. Therefore, the given statement is a false statement. Question 6. In covering a distance s meters, a circular wheel of radius r meters makes s upon 2 pi r revolutions. Is this statement true and why? Here, the distance covered by a circular wheel in one revolution is 2 pi r. For n revolutions, it is 2 pi r multiplied to n. That is the distance covered. So s will be equal to 2 pi r into n, and the n value will become s upon 2 pi r. So the given statement is a true statement. Question number 7. The numerical value of the area of circle is greater than the numerical value of its circumference. Is this statement true? Why? Let me consider the radius of the circle is r. Then area will be pi r square. For instance, let 0 less than r less than 2. Let me consider r value to be between 0 and 2. For instance, let r be 1.5. So area will become equal to pi times 1.5 whole square, which is 2.25 times pi. And the circumference is given by 2 pi r. Here it is 2 pi into 1.5, which is 3 times pi. So here the circumference is larger than the area. Therefore, area of circle is not always greater than its circumference. Hence, the given statement is a false statement. Question number 8. If the length of an arc of circle of radius r is equal to that of an arc of a circle of radius 2r, then the corresponding sector of the first circle is double the angle of the corresponding sector of another circle. Is this statement false? Why? Let me consider the two circles to be C1 and C2. Let the two circles be C1 and C2 of radii. One of the radius is given as r and one more radius is given as 2r respectively. And let me consider the lengths of two arcs be L1 and L2. As per the question, L1 is the length, say AB, of the circumference of the circle C1, that is given by 2 pi r times the angle form divided by 360. As per the basic definition, it is theta by 360 into the circumference. The same concept is applicable here. Let the arc CD of the second circle is taken. This will be equal to 2 pi r into theta 2. Here it is not r, it is 2r into theta 2 divided by 360. So here it is 4 pi r times theta 2 divided by 360. According to the question, we have the lengths equal, L1 equal to L2. This implies we have 2 pi theta 1 into r divided by 360 equal to 4 pi theta 2 into r divided by 360. Whatever get cancels, let's cancel that out. We have pi getting cancelled, r getting cancelled, 360 getting cancelled. Hence we are left with theta 1 equal to twice theta 2, because 2 ones are 2 twos are. Hence we have theta 1 equal to twice theta 2. Therefore the given statement is a false statement. Here the angle of sector of the first circle is twice the angle of sector of the second circle. So the given statement is not false. I must write here the statement is true. The statement is a true statement. Into theta 2 divided by 360 degree. Now the lengths are equal, so L1 equal to L2. This implies 2 pi r1 theta 1 divided by 360 degree equal to 2 pi r2 theta 2 divided by 360. Here this 2 pi 360 degree they get cancelled. We are left with r1 theta 1 equal to r2 theta 2. Here the area of sectors, let me write it as A1. This will be equal to pi r1 square theta 1 divided by 360. Let me consider A2. A2 is pi r2 square theta 2 divided by 360 degree. If I consider the ratio A1 upon A2, this becomes pi r1 square theta 1 divided by 360 into 360 divided by pi r2 square theta 2. Both this 360 and pi they get cancelled. Here we are left with r1 theta 1 into r1 divided by r2 theta 2 into r2. I have written r1 square as r1 into r2. These two are equal, hence I can cancel these two. Let me name this as 1. This is from 1. Hence we have got the ratio of the areas as equal to the ratio of the corresponding radii. Since they are equal radii, this will be equal to 1. This implies the area of sectors of both the circles are not equal. This is only possible if r1 equal to r2. So this particular statement is a false statement. Question 10. The areas of two sectors of two different circles are equal. So here the areas are equal. Is it necessary that their corresponding arc lengths are equal? So let me consider the areas with the radius r1, r2 and angle theta 1, theta 2. Here we get the relation r1 square theta 1 equal to r2 square theta 2. From this, if I take theta 1 by theta 2, this will be equal to r2 square by r1 square. Let me consider L1 upon L2, the lengths of the arc. This will be 2 pi r1 theta 1 divided by 2 pi r2 theta 2, we get r1 by r2 into theta 1 by theta 2. Here r1 into r2 square divided by r2 into r1 square, this becomes equal to r2 by r1. Hence, if r1 and r2 they are equal, then L1 will be equal to L2. But this condition may not be true. If r1 and r2 are equal, then only the lengths will be equal. Here it should not be any two circles, there should be two circles with the same radius. Therefore, the given statement is a false statement. With this question, I'll end today's session. There are 4 more questions to be discussed in this exercise. Let's do that in the next session, followed by exercise 11.3. Thank you.